All right, this lesson is about 9.3. It's similar to 9.2, but instead of doing a one-sided z-test for proportion, we're doing a one-sample t-test for population mean. So the t-value, or the t-statistics, is equal to the sample mean subtract the population mean, or at least when we assume to be the population mean, claim to be population mean, and divided by the standard deviation of the sample, divided by the square root of n. And here, H null is being represented where the mean, the true mean, is actually greater than the claimed mean in the population. Here, the true mean is something less than the claimed mean in the population. And here, the claimed mean is not equal to it. So we got the two tails again. We're still going to do the same four-step process. Where we're going to state, make a plan, we actually do the calculations, then we're going to state our conclusion. Here's our first example. A classic rock station claims to play an average of 50 minutes of music every hour. However, it seems that every time you turn on the station, there's a commercial playing. To investigate their claim, you randomly select 12 different hours during the next week and record what the radio station plays in each of those 12 hours. Here are the number of minutes of music in each of those hours. So we got 44 minutes and then so forth. Determine whether the radio station's claim is an overestimate of what they truly play at a significant level of 5%. So, in order to do this, we need to know the mean of this. They gave us a little short sample, so it should be pretty easy to find the mean. So I'm going to take out my calculator and plug in those values. So I turned it on, and I went to Stat and Edit. I've already plugged in all these values into list 1. So plug them all in there. And then afterwards, if I want to find the mean from that sample set, and to find the mean, I'm going to hit Stat, go to Calculate, one variable statistics with list 1. And I find my mean to be about 41.92 minutes. So we can say that the mean, the sample mean, is about 47.92 minutes. And our population mean is claimed to be 50 minutes of music. All right, so that part's taken care of. And let's start off with our state. So we're going to say that our H null is that the population or the radio actually does play 50 minutes of music. And our alternative is the radio plays something less than 50 minutes of music. And we're going to prove that. How are we going to prove that? So we're going to first prove that it's random. And they said that by saying that you randomly chose 12 people, so that's true. And then we're going to prove that it is normal. It's very easy to prove it's normal if we have more than 30 samples or 30 plus samples with central limit theorem. In this case, it's an issue because we only had 12 different hours. We only have 12 samples to go by, just these 12. So we can't actually prove that it's normal using central limit theorem. We actually have to actually graph it in our calculators and actually decide whether or not the histogram or the box plot looks normal. So we already have the list plugged in. To actually graph it, we need to change first we got to go to second stat plot. We'll turn it on. And I'm going to make sure this is on. Go down to a histogram. And then I'm going to hit zoom. I'm going to go down to number 9 where it says zoom statistic. And when I graph it, that looks, I can't say it's skewed looking at that. Like I can't say that looks skewed. It looks approximately normal. So I can stop right there. And I can say, looking at that histogram, which looks something like this. That is approximately normal. So I can just say it's approximately normal. I can accept that using that picture if this is on a short intersection. We got lots of ways though to check if it's normal with our calculator. We could go back to stat and we could go down to Instead of using histogram, you can use a box plot. And I'm going to use those box plots that have the little outliers posted on the side, the little dots. So when I actually graph it now, it doesn't show any outliers to the side. And this is kind of long, but it's still mostly towards the middle. So I can't say it's not normal. I can't say it's skewed. So looking at that, I still say even with the box plot, I could have drawn the box plot and shown that, well, that looks pretty normal. I mean, nothing's perfect. It's pretty close to normal. Or you could have used a normal quantile plot. So you went back to stat plot, and you could have gone down to this one, which is the normal quantile plot. Then plotted that one. If you notice, it's not one of those ones that curve off or make a J shape or some kind of candy cane type shape. This is pretty much in a row. Like it's pretty much in a row. So there's no reason to say this is not normal. So we have to accept that as approximately normal in lots of different ways. So I could use that, or I can use a quantile plot to show that that's still normal. And our last thing is was normal, random, and independent. So we're going to assume this is independent because we've got 12 different hours we actually took the values for, and this is over the course of a week, and I'm assuming the radio is playing every hour of the day for a week. So 12 hours out of whatever 24 times 7 is, it's going to be less than 10%, right? So 12, it's going to be less than 10%. So we can assume it's normal because for that reason. So we're going to say this is true, and we're going to write out why it's true. We're going to assume that 12 hours out of 24 times 7, which is 168 hours, is less than 10%. Is less than 10% of the time that the radio is actually playing. So it passes the 10% rule. So it'll be difficult to do the n times p is greater than 10 here because I don't really have a p-value to really work with in this case. So we just had to make sense of it, and that's enough to prove it. Let's get to the math now. So we did our state, we planned it out, we did this. Now we're going to do the do portion. We're actually going to do the math. So let's get a picture of what's happening. In this picture, what we know is our supposed population mean is 50 minutes of music. And what we know is our sample mean was 47.92 minutes. So it's here. And we want to know whether or not that would be unusual. Like how often would we expect that to occur in a sample? And we're going to use a t-test to do it this time. And the way we're going to use a t-test, there's a formula for the t-test in this situation on the front of the notes where we had to take the mean, subtract the population mean, our supposed population mean, divided by the standard deviation of the sample, divide that by the square root of n. So let me write that out real quick. So it's going to be t equals to the mean, take away the supposed population mean of the sample, or the other population, divided by standard deviation over the square root of n. So our mean was 47.92 in our sample. The proposed mean is 50 minutes of music. And if I go back to stat and calculate, S of x is about 2.81. So that's our sample standard deviation. So 2.81 divided by the square root of 12. If you plug all this in my calculator, I'm going to find that. So according to my calculation, that t-value is negative 2.564. All right, so I'm going to go to my t-table to find the probability of having a t-value at that level. But before I go there, I have to determine my degree of freedom, which is n take away 1, so it should be 12 take away 1 or 11. So my degree of freedom is 11, and this is the actual t-value there. I'm going to keep that in mind. I want to find the area for that space. So going to the t-table, All right, so the degree of freedom is 11, is this level, and I'm looking for the t-value to be negative 2.56. So looking around this row for 11, this is 2.39, and this is 2.71. So I'm using the positive in there, and you should be able to do this. So I know that the area is in between 0.02 and 0.01. There's something in between there because 2.56 is in between 2.32 and 2.71. So someplace in between 0.02 and 0.01. Let's keep that in mind. So that area is between 0.02 and 0.01, some value in between there. We didn't stay at significance level, so we're going to assume that significance level was 90, it was 95% confidence interval, or A is 0.05, and this value is less than 0.05, as well as this value is less than 0.05. So no matter what it was, it's improbable that if you claim to play 40 minutes of music every day, and I did a 12 sample survey, and I found you're playing on average 47 minutes, 47.92 minutes of music, that shouldn't have ever happened. So for that reason, we're going to reject the null. So we're going to conclude. That since the proportion of the p-value is in between 0.01 and 0.02, and this is less than 0.05, we reject the null. This means that the radio station does not play an average of 50 minutes of music every hour. So I use this A for area, and it's really our proportion. So P is what it is. That's it. That's all I have in that lesson. See you guys tomorrow.